Welcome to the first lesson in the unit of measurement. You should be watching this video as a way to check your work of the first self-assessment in the measurement unit. The stuff we're doing in this lesson, you should have some prior knowledge before we move forward in this course. So the first question says match each area to an object it could describe. Now, 4 square centimeters. A square centimeter is about the size of the end of your pencil. So if we were looking at something on this list, that would be 4 square centimeters. A postage stamp is probably the best object to describe that. 1 square foot, if you look down on the floor, there's some tiles usually on the floor of many schools. You can see those tiles are approximately 1 square foot. So something that would match 1 square foot would probably be about the size of a binder. Now 2 square meters and 1 square yard, obviously the one is smaller than the one that has 2 square meters. But 2 square meters, if you're looking again on the floor, it's about a 3 by 3 square. So 3 tiles on one side, 3 tiles by the other, 9 in total. Something that would kind of match that size would probably be a bed, a single bed. If I go down to the bottom, the 1 square yard, 1 square yard again is similar to that size. It's a little bit smaller, but 1 square yard would probably be the size of an average window. And 8 square inches would probably best be represented by a cell phone. So all of that knowledge, these are called what we would deem reference, where we would have some kind of estimation on the thing we're thinking about. If we go down to this page, here's some more stuff that you should know from other levels of math. We should know that this little thing up there, this is called an exponent, and if we were to evaluate this, that actually means take whatever is in the brackets, so 23.5 meters, and times it by 23.5 meters. Now if you were to do that in your calculator, bring one up here, it's like saying 23.5 multiplied by 23.5. And that gives us 552.25. So that takes care of the number portion. But now when we have meter times meter, that gives us a square meter. Down below in the next example B, it's actually saying what is the square root of 25 square centimeters plus 144 square centimeters. Now we need to add the things under the radical sign first. So 25 plus 144, that's 169. So now it's asking what is the square root of 169? You can either think in your head what is one number that multiplies by itself to get 169. You could use some technology to help you out here. We could say what is the square root of 169, and this will tell us 13 because 13 times 13 equals 169. So this answer is 13. The last few examples on this page, you may have had to look up some formulas to help you out here, but it says the area of a polygon is the number of square units of space that it covers. Name each polygon, then determine its area. So first thing, we're going to look at the first shape up here. This is a 5 by 4 polygon, and we should know that this thing is called a rectangle. And the area of any rectangle is taking the length of one length of it and multiplying it by its width. So if we looked at this, the length is 5, the width is 4, which gives us an area. 5 times 4 is 20, and we can't forget our units. This is feet times feet, which would say that this is 20 square feet, this rectangle. Moving next to it, this is a triangle, and the area of any triangle is the base of it times the height divided by 2. The base of this triangle is down here, what it's sitting on. So this is 6 times the height. The height in any triangle has to make a 90-degree angle with its base. So we have 6 times 8 divided by 2. 6 times 8 is 48, divided by 2. That gives us 24 square units, and our units in this case are centimeters, so it's 24 centimeters squared. We always need to include our units. The bottom two shapes here are something that you would have come across in junior high. The first shape is kind of like a kicked over rectangle. This is a parallelogram. The parallelogram has a similar formula to a rectangle, except we say the area of the parallelogram is base times height, because the width on this is kind of slanted, so it'll give us a little bit of a problem. So if we're looking, base and height, whenever we see these when we're talking about areas, bases and heights need to make a 90-degree angle with one another. So here's the base, which is 17. This height makes a right angle with it. That's 11. And using your calculator, 17 times 11 gives us 187 square units, and in our case, the units are meters. So we have 187 square meters. The last shape is one that you don't have much practice with in junior high coming into the course, but this is called a trapezoid. And trapezoids, probably on this sheet, have the most complicated of formulas. The area of a trapezoid is taking the two bases and adding them up, dividing them by 2, and then multiplying by the height of the trapezoid. Now the bases, remember I said whenever we talk about base and height, these things need to make a 90-degree angle with one another. So I have two bases. The one base is the 18, the other base is the 8. So in a parallelogram, the bases need to be parallel to one another. So here we're going to say 18 plus 8. We're going to divide that by 2. Those are our bases. Now the height has to make a 90-degree angle with them. There's my height of 6 inches. So I'm going to multiply this whole thing by 6, which would say bed mass or order of operations say we have to do what's in the brackets first. So we have 18 plus 8 divided by 2. Again, a calculator can help you. That determines to be 13. Multiply that by 6. The area of this trapezoid is 78 square units, and we can see our units are inches. So this is 78 square inches. So now let's take a look at area and circumferences of circles. So we'll start with the area of these circles. The formula for an area of circle is pi times whatever the radius is squared. So that really means pi times the radius times the radius. The radius is the distance that's from the center of the circle to the edge of it. So our area here would be pi times the radius squared. Now many calculators have a squared button. If yours doesn't, it's the same thing as saying what's pi times the radius twice. So basically pi times 9. And I'll bring up the calculator to show you. This calculator does have a pi button. So I can say pi times 3 times 3. And this tells me that the area of this circle is approximately, now we're going to have to round because pi is a number that never ends, it's approximately 28.27 square yards. And we could say yards squared. So that's the area of that circle. Likewise, if we look at the area of the second circle, this one's saying that all the way across this circle, so from edge to edge is 8, and the area formula is pi r squared. I need the radius, so I need to know that the radius is only half of that distance. My radius is going to be 4. So I'm going to have area is pi times 4 squared. And again, I'm going to show you what this looks like on the calculator, and I'm going to use the squared button this time. So I'm going to say pi times 4, and I have a squared, so pi times 4 squared, again rounding, that would be 50.27 square in this case meters. 50.27 square meters. Now we're going to examine, because the question also asks us to find the circumference of these circles. The circumference of a circle is all the way around the circle. Now there's two formulas for circumference. One of the formulas is 2 pi r. So if I know the radius, I can use 2 pi r. On the other circle, since I have the diameter, I can use pi times the diameter. It doesn't matter which one you use as long as you're using either the radius or the diameter. So in this first example, this is like saying the circumference is 2 pi times 3. So again, we'll look at what that means in our calculator. 2 pi times 3. So I get 2 times pi times 3. My radius is 18.85 yards. So the circumference, 18.85 yards. What that means to us is that if I was to put a string all the way around this circle and then stretched it out straight, it would be 18.85 yards long. Over here, circumference is pi times the diameter, so pi times 8. And looking on your calculator, that would be 25.13 meters. So all the way around this circle, again, if we were to lay a string or a rope and stretch it out straight, it would be 25.13 meters. Now the last two questions on this sheet talk about a girl named Tula, and it has a picture of the aquarium we're talking about down here at the bottom, and it's saying Tula works in an aquarium store. She uses the area formula to estimate how many fish can actually go in this aquarium. Freshwater tropical fish have this formula, so if I could find the area of the top of the tank and then divide it by 12 square inches, that'll tell me how many fish she can put in here. So it's saying how many tropical fish can she actually put into this aquarium. So down below, if we're looking, the top of this fish tank right here is just a rectangle. It's a rectangle that is 18 inches by 48 inches. So if I could find the area of this and then divide it by 12, that's going to tell me how many fish she could fit in. So the area of a rectangle is length times width. The area of the rectangle in this case is going to be 48 times 18, which means the area of my rectangle is going to be 864 square inches. Now it says if I want to figure out how many fish can fit in there, a good estimate is 864 divided by 12. This is what the equation says. So that means she should be able to fit in about 72 fish into this aquarium. The final question on this beginning pre-assessment is saying if this is actually Tula's fish tank, it's saying what is the total area of all the outside surfaces in square inches? So if I look at this, it says include the top and bottom. I have this rectangle, which would be exactly the same size as the rectangle on the bottom. So if I was to name the number of sides, I have a top and I have a bottom. So there's two sides I need to worry about. The top and the bottom, that's 18 times 48 because they're rectangles. So this would be 864 square inches. But the bottom is exactly the same size. So that's going to be 864 square inches as well. Now, if I was to look at another part of here, we have this rectangle on the end. Now, the question does say that this is 24 inches high, and it's still 18 inches wide. So if I was to look at that side, or part 3, that would be the exact same as that other end of it. So I'd have two sides of this that are 18 by 24 inches. So if I multiply those, I should get 432 square inches for the one side, and the other end of it would be the same thing, 432 square inches. Now the last part I need to look at is this big front piece of glass on the aquarium. It's 48 inches long and it's 24 inches high, but the back side of this aquarium would be exactly the same. So I would have 6 sides in total, the last one being 48 by 24, and my calculator could tell me that's 1152 square inches. That would be the exact same size as the back of it. So all of these things combine to what we call to be our surface area. So the surface area, or the area of all the sides on this aquarium, when I add that up, is 4,896 square inches.